So today we are going to start with a different type of curve, and that is called the ogive. First, we are going to look at the definition. When we say ogive, it's a graph that represents the cumulative frequency for the class in a frequency distribution. So here we are drawing the graph of the class, okay, a graph between the class and the cumulative frequency. We already know how to find the cumulative frequency from last class. So for example, in this problem here, you can see they have given the class, different class sizes are there, and then we have the frequency. What we need to do is now we need to find the cumulative frequency. So let's find those cumulative frequency here. Let me begin writing that. Cumulative frequency for the first, it is 5. How much will be the cumulative frequency for the second? Anybody can speak, it's okay.
5 plus 12.
5 plus 12, that's right, which is 24, right? 17, right?
17.
I'm just kidding, 17. Okay, 17 plus 10?
27.
27, there we go. 27 plus 8. How much is that?
35.
35, very good, 35. And then 35 plus 3.
38.
38. And then 38 plus 2.
40.
See, we are doing little math. We are starting with the addition. It will be fun, okay? So we have the cumulative frequency. Now we are going to create the ogive. So it is the graph between these classes and the cumulative frequency. So along the x-axis, you are going to draw those classes. So the first class is from 50 up to 60. The next is 60 to 70. It is continuous. 70 to 80, 80 to 90, 90 to 100, and 100 to 110. So we have these classes along the x-axis. And then along the y-axis, you draw those cumulative frequencies. So along the y-axis here, we'll have those cumulative frequencies. And you can see that your cumulative frequency goes from 5 all the way up to 40. So you can choose your own scale. I'm going to count by 5. So 5, 10, 15, 20, 25, 30, 35, and 40. So you can use your own scale to fit the length of the y-axis that you have here. So in my case, I use the 5 and it fitted nicely. Now what we are going to do is we are going to plot the points, and the way we plot the points for 50 to 60, we use the midpoint. Okay, we use the midpoint. So 50 to 60 midpoint is somewhere here, 55, and the cumulative frequency is 5. So we'll plot that point there. Do you understand how I did that? So this is the class 50 to 60. Can you see my mouse moving there?
Mm-hmm.
Okay, 50 to 60. For that, the cumulative frequency is 5. And then now for 60 to 70, for this one, the cumulative frequency is how much? Look here, 17, right? We go to the height of 17 now. So your 17 should be somewhere here. Did I do it right?
Yeah.
Okay, so if you want, you can start joining right now. That's okay. And then the next one is 35. So 35, we go from here. This is for, which one is that? Is it 35? 27, right? 70 to 80. This one is 27. So we'll go up to 27. So 70 to 80, we go up to 27, which is here. Can you see that?
Yeah. Mm-hmm.
Going like that, it's continuously increasing. It may or may not be a straight line. It will not be a straight line, but it is continuously increasing. You can see they are increasing. The next one is 35. So for the next class, 80 to 90, 80 to 90, it is 35, which is right there.
Mm-hmm.
So you can see it is not exactly a straight line, but increasing, right?
Yes.
And then 38, little bit above that, not much, but a little bit above that. 38. And what is the cumulative frequency for the last class?
40.
40, right?
40.
All the way at the top. There is one. Right there, it is 40. So we'll do that. 40. Let me show you here. A little bit up. Can you see that?
Mm-hmm.
So this curve that is drawn here, the curve in the red, this is called the ogive. Ogive. I think they call ogive. Oh, give me. It's not something like that. I used to look at the word, and when I was a student, I think it was ogive, but my teacher used to call it ogive. So I hope this is ogive, right? Okay, so there is one important thing that you need to know from this ogive. The ogive will give you the total number of observation in the given data set. So by looking at the ogive, you can tell how many number of observations are there. If you look at the table, you know that when we add all these frequencies, it is 40, right? The sum is 40. We can directly tell that if this data set was not given to you, but if this graph is given to you, the ogive is given to you can find the frequency corresponding, cumulative frequency corresponding to this top point on the curve. If you come across, you'll see that it's 40. So we know that the total number of observations is 40. So ogive will give you directly the total number of observations in the given data set, even when this data set is not given to you. If just the graph is given to you, you can easily find the total number of observations. Any question on this one? Any question on ogive? Waiting on your response. Yes.
I Googled the pronunciation of the word.
Uh-huh.
Because I was curious, and they sort of say ojai.
Ozai?
With a, like, almost like with a J, OJ. So let me play the Google pronunciation.
Okay, please go for that. One more time, please. Ogive. Okay.
Ojai.
Okay, got it. Thank you. Not G, but kind of Z, right?
Kind of a J.
Yeah.
Ojai.
Ogive. Okay. Thank you for that. Any other comment or anything on that?
I was just curious.
Yeah, thank you for doing that. Okay, we'll move forward. Okay, next, we are going to work on a next type of graph. It is called the bar graph. First, we are going to look at the definition of the bar graph, and we are going to learn how to construct the bar graph. So when we say bar graph, a bar graph or a bar chart is a chart or a graph that presents the categorical data with rectangular bars with height or the length proportional to values they represent. So you can see that the definition of bar graph is quite similar to the definition of histogram that you have seen in the previous class. But the difference here is, although this also represents the categorical data, here, this is not for the continuous data. So what you'll see here is the bars will not be connected to each other like in histogram. The bar will be separated there. So bars can be plotted vertically. When you draw the bar diagram, the bars can be plotted vertically or horizontally. You can do it either way, but the trend, the most common trend is we try to draw the vertical bars while creating the bar diagram. A vertical bar chart, sometimes called the column chart. So if you look at the Excel, sometimes you'll see they call the vertical bar chart as the column chart. So that is the definition of the bar graph. Let's look at the example here, and I think it will be more clear what I'm talking. So let's see what is given here in this example. The table below shows the average amount of money spent by high school seniors. We are asked to construct a bar diagram to represent the data. And the information given here are, let's see what information is given to us. Electronics, $1,000, school supply, $250, clothing, $145, shoes, $85, others, $200. So the information is given to you, and you are asked to create the bar graph for this one. So along the x-axis, we will have these items. What are the different items on which we have this spending? So the items or the categorical data will go along the x-axis. So along the x-axis, we'll have those items. The first one is electronics. I'm just going to write in short, electronics, school supply, and then clothings. Okay, clothings. Then we have shoes and others. So we have the items along the x-axis. Then along the y-axis, we'll plot the amount of money they spend in each item. So along the y-axis, we are going to plot the amount spent in dollar. That's the amount. Now, what we'll do is we'll look at this data set. You can see that the minimum value here is 85, and then we go up to 1,000. So along the y-axis, you have to scale accordingly. So what I'm going to do is I'm going to scale by 100. So I'm going to count by 100. So 100, 200, 300, 400. I know it's difficult for me to fit here. 500, 600, 700, 8, 9, 10, it's a little bit above that. 1000 is 1000. So you can kind of visualize, right? It's up there, okay? Can you hear me?
Yeah.
Okay. I was not able to show all the numbers here. I'm just going to leave it here, but we'll be able to fit the information there somehow. Okay, first one is electronics. It is 1000. So what we'll do is we'll draw a bar of height 1000 around this electronics. So we'll go up like this. Maybe 1000 is up to there. So this represents the electronics, and the total cost for this one is 1000. You can write that 1000 on top of that. And if you want to beautify your bar, you can shade it, you can color it, you can make it beautiful, because by drawing the different types of bars charts, we are representing the data, and we want to do it in a beautiful way. So that is the first one. Okay. School supply, how much is that? $250, right? I can easily fit that over here. So school supply, you draw a bar over there. They are not connected now. You go up to $250 like that. So that is $250 school supply. Is it going good?
Yeah.
Okay. Then the third one is clothing, which is $145. So let's draw that bar there with a height of about 145. So it will be something like that. $145, 145. Okay. And then we have shoes, $85. 85 should be something like that, a little bit below 100. So 85 for shoes. And then $200 on other items. So $200, so the height will be something like this. I think I have to make that a little tall and wider like that. Okay, $200. So this diagram I created here, this is called the bar diagram. Is it looking beautiful?
Yeah.
Yeah, there we go. Okay, so the advantage of bar diagram is you'll be able to visualize the categorical data easily, and by looking at this bar diagram, you can easily tell in what item the spending is the most. So by looking at the bar diagram, if just the bar diagram is given to you, you can easily tell they have large amount of spending on electronics, right? Can you see that?
Yes.
Okay, yeah, that's very true. If you try to visit some high school students, okay, and if you want to check with them, They might be taking some statistics class. They may not have calculator, but they'll definitely have iPhone 11, you know? What do you think? Okay. Any question on bar diagram or bar graph? Yes, no?
No.
No question. Okay. Okay. Here is another problem. And in this one, this is the application of bar diagram. It's a quick and easy problem. So if you look at this, let's see what is asked here. Let me use a different color here. Okay. The following bar graph represents or presents the average amount of certain families spend in dollar on various food categories in recent year. On which food category was the most money spent? So most money spent, that corresponds to the tallest bar, right?
Yeah.
Mhm.
So by looking at this bar diagram here, on which item they spend most money? Say that again.
Meat, poultry.
Meat,
Fresh.
poultry, fish, eggs, right?
Mhm. Yeah.
Okay. So let me write that. Most spending is on, the category is meat, poultry, fish, and eggs. Is that easy? Here we just learn how to read the bar graph. We just look at the bar graph and we answer the question. Okay, next one is a special type of bar graph, but we don't call it bar graph. Instead, we call it Pareto chart. So what is a Pareto chart? First, we are going to define this. A Pareto chart is used to represent the frequency distribution for a categorical variable, just like the bar graph. And the frequencies are displayed by the height of the vertical bars, which are arranged in order from highest to lowest. So while drawing the bar diagram, we don't look at the frequency, we don't look at the amount, we just draw. So you may have a shorter bar first, then tall, maybe short. So there is no increasing or decreasing order of the bar in a bar graph. But here in Pareto chart, what we do is we'll have the category with the highest frequency first, and then we'll have everything in descending order. So let's see what is the meaning of that using this example here. In this example, let's see what is given and what we are asked to do. The following frequency distribution presents the frequency of passenger vehicles that pass through a certain intersection from 8 a.m. to 9 a.m. on a certain day. We have to construct Pareto chart for this data. And the data given here is we have motorcycle, 7 of them, sedan 22, SUV 58, and then truck 67. So when you list the category along the x-axis, okay, when you list the category along the x-axis, we must have the one with the highest frequency first. So here, which one has the highest frequency? Look at this. Which?
CUV. No. The truck.
The truck. Okay. So first we have truck. Truck. What is the next?
This SUV.
SUV. Very good. SUV. What is the third?
Sedan
Sedan. Okay.
and motorcycle.
And motorcycle. I'll write MC for motorcycle. So we'll have the vehicle type along the x-axis. Vehicle type along the x-axis. Now along the y-axis, we must have the frequency. Frequency along the y-axis. And then you can see that we have the frequency up to 67. So probably I have to go by 10 again, with the hope that I can fit this time. 10, 20, 30, 40, 50, 60, 70. So I can fit that 67 easily, right? Yes, no? No one wants to talk with me? Okay. So the frequency for the torque is 67. So we are going to draw a bar of height 67 first. So let's draw that, the bar with the height of 67, which is pretty close to 70. 67. You want to make it beautiful, you just do this. I'll put some color. I'm going to check your work later on, the note catcher, and I can find how beautiful you'll make. SUV, we have 58. Somebody is saying something?
Mm. Never mind.
I would love to hear that. No one wants to talk with me. I'm a little
Nothing.
sad.
We're making it pretty for you.
Oh, okay, good. There we go. So 58 is the second, so that is the height. You can see the first one is the tallest bar. Now the second one has a little shorter height compared to the first one. Now third one is 22, so it will be still shorter. It will be somewhere here, 22 for sedan. Okay, 22. And then the last one, we have motorcycle, only 7 of them. 7. This data must be taken, or they must have made the observation in December. So we have less motorcycle there, right? So you can see in this bar diagram, actually it's a bar diagram, but what's going on here is we have the tallest bar first, then the height of the bar is decreasing as we go from left to right. So these type of bar diagram, it is called the Pareto chart. Questions, if any? No question, okay. Okay, next type of representation of data is using a pie chart. Whenever you heard the word pie, what do you think of? Apple pie?
Pie to eat.
Pie to eat? Okay, I can
Very
understand. Yeah, pie to eat, I totally understand. But because I am so much doing math every single day, when I hear the word pie, I remember this pie. Can you see that pie?
Oh yeah,
Oh,
remember that. Like
Pie,
the
yeah.
areas.
But,
Okay.
right. But here, when we say pie, it is a circular diagram, okay? When we say pie chart, it is circular diagram to represent the categorical data. So a pie chart is a circle. You can see a pie chart is a circle that divides into sector or wages according to the percent of frequency in each category of distribution. So what we have to do is in creation of the pie chart, we have to draw a circle, and then in that circle, we have to put this category based on the percentage. So in the example here, if you look at the example here, the following information shows the color of car preferred by customer. We are asked to draw a pie graph and indicate how many degree that black represent in the pie graph. Okay, that's interesting. First, we are asked to draw the pie diagram or pie graph. So for that, what you have to do is we draw a circle. It's a circular diagram, so we draw a circle. You can also create a circle in your note catcher. So draw a circle. Is my circle looking beautiful?
Yes.
What do you think? Do you think that my circle is beautiful? No?
That is good.
That's good. Okay. So now what we are going to do is, in order to find the, or in order to create the bar diagram, we need either the percentage, okay? We need either the percentage or we need the degrees. How many degrees? So how we are going to find this, it's not that difficult. What you have to do is, around a circle, how many degrees are there around a circle?
360.
360 degree. Total is 360 degrees. So if you add all these numbers, let's see, what is the total? Please use your calculator and find the total. Please do it. What is the total?
200.
200. Very good. So meaning of that is 200 is equivalent to 360 degrees. So 200, you can say, let me write somewhere here. 200 is equivalent to 360 degree. Okay, so we have to find degree for each of these values. 200 is the total, so that is 360 degree. So what is the value for each of them we have to find? So when I say 50, okay, what will be the degree value for that? So in order to calculate that, the easiest way is you do this. If you want to find how much is 1 equivalent to, you divide 360 by 200. How much is 360 divided by 200 in your calculator? 1.8, right? Yes. So 1 is equivalent to 1.8 degree. So 50 is equivalent to how many degrees? So 1 is 1.8. That means we have to multiply each of these. We have to multiply each of these by 1.8, because 200 times 1.8, if you try, 200 times 1.8 is 360. Okay. 200 times 1.8 is 360. That means we can multiply each of these by 1.8. So the first one is
Sorry,
50 times 1.8. What is it? Is it 90 degree? Okay. How much is 60 times 1.8? I got 108. Is that right? Make sure you do it in your calculator and see whether I'm getting these values correctly. If not, let me know. Are you doing it in your calculator?
Yeah.
Yes, no? Okay, 72 degree. You can also try adding these numbers to see whether it is equal to 360 or not, like 90 plus 108 plus 54 plus 36 plus 72. Is it 360 degree? Yes, right? Okay. So what you'll do is, after we have all these degree values here, so go to the center of the circle and then draw the radius. Now the first one we have is the rate collar. Rate is 90 degree. So you are going to mark a 90 degree, approximately 90 degree in your circle. Do you think this is 90 degree?
Yes.
Yes. And this represents rad. Rad 90 degree. You can beautify. You can shade, you can do whatever you want. Just make it beautiful. Okay, that is rad. Then the next one is black. Black is 108 degree. So 108 degree is black. So I'm going to draw here. So you can see that this will be 90 degree again, right? Is that right?
Yeah.
Yes.
But I need 108. So it will be more than that, even more than that. So let's do a little bit more than that. So meaning is it should be something like this. This should be 108 degree and it is for black. Can you see that? It's getting beautiful, right?
Yeah.
Yeah, I'll be happy when you say yes. Then after that, we have white, which is 54 degree. So it is even less than 60 degrees. So it should be maybe like that. This is 54 degree and this is white. I don't have white color to paint. Maybe I have, but yeah, look at that. Can you see white there?
Yeah, we can see that.
Okay, I'm doing everything possible. Then after that, we have green, 36 degree. So green is, after white is green. Where is my green? Oh, here is green. Green, 36 degrees, so something like that. This is green, 36 degree, green. There we go. And the remaining, whatever is remaining there, that is blue. Which color is blue? Maybe that's blue. Okay, 54 degree. This is blue. Okay, that's my blue. So this is the pie diagram. Is it looking beautiful? Is not it beautiful? Look at that. I like it. Okay, great. So here we were able to create the pie diagram. This is the quick visualization of the diagram, I mean the data. And you can see that by looking at the pie diagram, you can easily tell which one has a more percentage and which one has a less percentage. Definitely the black has a more angle, so it is more percentage, right?
Isn't blue supposed to be 72 degrees?
Oh, that is typo. I'm sorry. 72, you're right. That is 72. Thank you so much. Yes, that is 72. The remaining is 72. Okay, great. Now we have one question here. Say that again.
Can you explain one more time how you got those degrees?
Definitely. What I know is I'm pretty sure this session is about to expire. If we disconnect, make sure you connect back, okay?
Mm-hmm.
Okay, what we do is, see, when you add all these numbers, it is 200, right?
Mm-hmm.
So 200 is equivalent to 360 degree, okay? So you have to multiply 200 by how much to get 360. We are going to find that first. So in order to do that, what you can do is divide 360 by 200. So if you divide 360 by 200, so for 1, it is equal to 1.8. So first you have to get that, okay? Meaning of that is the number 1 is equivalent to 1.8 degree. Because if you multiply by 1.8, 200 times 1.8, you'll get 360. So you multiply each number by 1.8, 50 times 1.8, 36 times 1.8, 30 times 1.8 to get 54, 20 times 1.8 to get 36, 40 times 1.8 to get 72. So if we multiply by 1.8, we get this. And the way we get that 1.8 is always divide the total angle 360 by the total value you'll get here. So 360 divided by the total will give you the conversion factor of 1.8. So this number will help you convert all the numbers here into degrees. Does that make sense?
Yes. Thank you.
Okay, great, great. Any other question on this pie diagram? You have a question? No? Okay, let's work on this last example and we'll end this session. Then we'll come back and work on one more thing. But here is one quick example on the pie diagram. See, they have given the pie diagram already, and this is given in terms of percentage. When it is given in terms of percentage, the total percentage is equal to 100%. And the question here is, following pie chart that presents the percentage spent by certain household on its 5 largest annual expenditures, like food, housing, utilities, and insurance. The question is, what percent of money spent was spent on food, housing, and utilities? So it is just reading the graph. So by looking at the graph, how much is spent on, what percent of money is spent on food? You have to write what is spent on food, what is spent on housing. This is just reading the pie diagram. And what is spent on utilities. So look at the pie diagram and tell me how much is spent on food. What do you see?
22.1%.
22.1%. Very good. How much is spent on housing?
29.5%.
29.5%. Very good. And then how much is spent on utilities?
14.7%.
14.7%. So what we have done here is we learn how to create the pie diagram, and also we learn how to read the pie diagram. Here what we did is we draw the pie diagram manually using the traditional calculation procedure. If you look at the lecture videos posted on under the module, they are, or in those lecture videos, I created the pie diagram using Excel. It is much easier. You don't have to do math over there, but make sure you watch that also, and whichever is good for you.